Welcome to Two Beans in a Pod. Something pretty significant just happened up on the sun. And it actually has the potential to ripple down and affect our lives in some, well, surprising ways. We're talking about a recent, rather energetic solar flare.
Yeah, you might have seen some headlines buzzing about solar activity. It's definitely been active. What we want to do for you today is really dig into what this recent sort of surprise burst from our star means on a practical level. We've looked at the news reports, the NASA info you shared, and our goal is to understand not just what happened, but the potential effects, and crucially, what you can maybe do to be a little more prepared.
Exactly. And no need to feel like you need a physics degree to follow along. We're going to try and break it all down, highlight what's important, maybe those moments where it all clicks. Our mission today really is just to give you the info you need without drowning you in jargon. So let's jump right in. The sources you sent over, they detail some pretty intense solar activity around mid-May 2025.
That's right. It kicked off around May 13th. We saw some action from a sunspot region called AR 40086. It popped off an X1.2 class flare. Now think of sunspots as these active zones, right? In that first flare, it caused some minor radio fade-outs over the Americas.
Yeah.
Nothing too major, but a sign of things to come.
Okay, so like a little preview.
Kind of, yeah. But the real focus quickly shifted to a new region, AR 4087. By May 14th, this area was showing signs of some serious magnetic energy building up, real tension.
And that tension didn't last long, did it?
No, not at all.
We got a bit of a warning shot first.
Yeah.
An M5.3 class flare.
That's it. Probably caused a few more radio hiccups.
Yeah.
But then,
Then the big one.
yeah, just a little while later, 4:25 a.m. Eastern Daylight Time on the 14th, AR 4087 just let loose. A powerful X2.7 class flare.
Wow, okay. X2.7. Can you break down what those letters and numbers mean? X class sounds serious.
It is. So the classes go A, B, C, M, and X. X is the top tier, the most powerful, and importantly, it's a logarithmic scale. Each letter step is 10 times more energetic than the last.
10 times. So M is 10 times stronger than C, and X is 10 times stronger than M.
Exactly. And within the X class, the number matters too. So an X2.7 flare is nearly 3 times as powerful as an X 1.0 flare. It's a significant jump.
Okay, so proper blast. And what causes these things? Just the sun burping.
Well, sort of. It's all about magnetism. The sun's surface has these incredibly complex magnetic fields. Sometimes the field lines get tangled, stressed, twisted up.
Like stretching a rubber band too far.
Kind of like that, yeah. And then suddenly they snap and reconnect in a new configuration. That reconnection releases a huge amount of energy very quickly.
And that energy comes out as...
Heat, intense light across the spectrum, and acceleration of charged particles. It heats the surrounding gas to millions of degrees. Bang! A solar flare.
millions of degrees. Right. And you mentioned these X-class flares are more common now.
They are. We're currently in or very near what's called the solar maximum. It's the peak of the sun's natural activity cycle, which runs about 11 years. So yeah, late 2024 or 2025, we expect to see more of this kind of intense activity.
Okay, so this big X2.7 flare goes off. What happens here on Earth immediately?
The immediate effect was a pretty significant radio blackout. It was classified as an R3 level, which means strong on the space weather scale.
R3, okay. And who felt that?
Anyone using high-frequency radio communications on the sunlit side of the Earth at that moment. So because of the timing, that was mainly across Europe, Asia, and the Middle East.
What kind of communication is that?
Think pilots talking to air traffic control, sailors communicating ship to shore, ham radio operators, that kind of thing. For them, those frequencies basically just vanished. Static or complete silence.
Wow. For how long?
It could last up to an hour in some cases. Imagine flying a plane and suddenly losing that primary contact. It's definitely disruptive.
Yeah, no kidding. Why does the flare affect radio waves like that?
It's about the Earth's ionosphere, specifically the lowest layer, the D layer. The intense X-rays and UV radiation from the flare hit this layer and dramatically increase its density, ionize it more.
And a denser layer means?
It means it absorbs those high-frequency radio waves instead of reflecting them or letting them pass through like it normally does. Hence, the blackout.
Okay, so immediate radio problems. But you also mentioned these things called CMEs, coronal mass ejections. They sound ominous.
They can be, yeah. Now, this particular X2.7 flare didn't immediately launch a major CME right at Earth, which is, fortunate.
Yeah.
But scientists were definitely on high alert. CMEs often follow strong flares. They're these enormous clouds of plasma, charged particles that get flung out from the sun.
Not just energy, but actual stuff being thrown at us.
Exactly. Billions of tons of solar material traveling at incredible speeds.
And if one of those hits Earth?
That's when we can get geomagnetic storms. These usually happen a few days after the eruption because the CME cloud takes time to travel across space.
Right. And geomagnetic storms, they're not just about the northern lights getting brighter, are they?
No, although that is one effect. But they can have serious consequences for our technology. They can induce currents in long conductors, like power lines, potentially overloading transformers and causing grid problems, especially at higher latitudes.
So power outages?
Potentially, yes. They can also disorient satellites, maybe even damage their electronics. They mess with GPS signals, making them less accurate or unavailable.
GPS, okay, that affects a lot of us daily. Phones, cars.
Absolutely. And the concern with this recent event was that AR4087, the sunspot region, didn't just quit after the X2.7 flare. It remained really active. Hours later, it fired off another big one, an M7.7 flare, still strong.
Still packing a punch.
And critically, the sun rotates, so this active region was turning to face Earth more directly.
Increasing the odds that any future eruptions might be aimed right at us.
Precisely. That's why NASA issued warnings, saying ongoing flares from this region could impact, and I quote, radio communications, electric power grids, navigation signals, and pose risks to spacecraft and astronauts.
Okay, that covers a lot of ground. So bringing it back to you, our listener, what should you take away from this? Should people be worried?
Worry isn't productive, but awareness is. It's about understanding our vulnerabilities. Think about how much you rely on technologies that could be affected. GPS is a big one. Radio, if that's part of your work or hobby. Even just the stability of the power grid.
And is there any direct danger to us physically, like from the radiation itself?
Thankfully, no. Not for people on the ground. Our atmosphere and Earth's magnetic field do an amazing job protecting us from the direct harmful radiation from flares. Astronauts outside that protection are a different story, of course.
Right. But the indirect effects, the disruption to technology, that's the real issue for most of us.
That's the key concern, yes, the infrastructure.
So any practical steps people can take, just in case?
Well, it depends on your situation. If you do rely heavily on HF radio, like for sailing or remote work, maybe think about having a satellite phone or another backup communication method.
Okay. And for the rest of us?
For potential power outages, which, let's be honest, can happen for many reasons, not just solar storms. Having a basic emergency kit is just smart planning.
Yeah, good point. What's in a basic kit?
Things like flashlights or lanterns with extra batteries, non-perishable food for a few days, jugs of water, a first aid kit, and importantly, a way to stay informed if the power and internet are out. A battery-powered, or even better, a hand-crank radio is invaluable.
To listen for official updates and news.
Exactly. And speaking of official updates, pay attention to alerts from space weather agencies like NOAA's Space Weather Prediction Center. They're the ones monitoring this stuff 24/7.
Good advice. All right, quick pause here. If you're finding this deep dive into solar flares interesting, maybe a bit eye-opening, do us a favor and hit that like button. It really helps other people find this information. And definitely subscribe so you don't miss our future deep dives into topics that matter.
Okay, so we've covered the flare, the immediate effects like radio blackouts, the potential for CMEs and geomagnetic storms. What's the final thought here for you, the listener? I think the main thing is that this event, this X2.7 flare, it's a really potent reminder, a reminder of the sun's immense power and how connected, how dependent our modern world is on technology that can be affected by it. Scientists are constantly watching, learning more, getting better at forecasting, but understanding the potential consequences yourself is the first and maybe most important step towards being prepared.
And it's not like this is over, right? You said we're in solar maximum.
That's right. This isn't a freak one-off event.
Yeah.
The sun has cycles, and we're in an active part of the cycle right now. So the potential for more flares, more CMEs, more geomagnetic activity, it's real. It's expected, actually.
So the takeaway is stay informed, maybe have some basic backups ready, and just be aware of how things like GPS and power grids could be vulnerable.
That sums it up pretty well. We've gone through the science, what happened right away, what could happen next, all based on the info you shared. Hopefully this is giving you some valuable perspective, maybe a clearer picture of what to keep in mind moving forward.
Yeah, and here's something maybe to chew on after this. Think about how deeply our modern lives are tied into technologies that literally depend on things happening millions of miles away, or even signals from space like GPS. The sun gives us life, obviously, but it also throws these curveballs. So the question becomes, how do we build more resilience? Both in our big systems, like the power grid, but also for ourselves individually. How do we prepare for these natural forces? It's definitely something worth thinking about.
It really is. Thank you for listening to Two Beans in a Pod. If you are interested in emergency goods, please order them from the link below.